Alright, hi everyone, this is question number 13 from our revision paper P5 set A, paper 2, question number 13 with regards to area of triangles. Okay, let's take a look at the question. In the figure below, two identical right-angled triangles ABC overlap to form a square of area 9 square centimeters. AB equals to AC. Find the total area of the unshaded parts. Okay, I've done my first reading. Let's take a look at the question again. It says here two identical right-angled triangles ABC. Okay, it says two triangles, but how come there's only A, B, and C? Usually you go triangles A, B, C, D, F, but there's only A, B, and C. So that's the point where you need to study the diagram now. The figure here shows you where's A. You notice that there are two A's here, two B's, and two C's. So it shows that, okay, this first triangle, A, B, is it this A? No, that's not this A. It's actually the corner. So I need to look at the corner. A, B, and C. And then I have another identical triangle. Let me use green color, which is these A, B, and C. And they overlap to form a square of which the area here 9 square centimeter. Okay, that's what it means. Okay, AB being the measurement here, equals to AC, which means identical this triangle and the other triangle, both triangle as well as isosceles, because they are equal. Find the total area of the unshaded parts, that means the white color portions that's not shaded. Okay, now with this information, let me try looking at ABC and see the two triangles and try to pull them apart. If I see these two triangles and they are overlapping, so can I lift them up and put them apart? Okay, so that's my first reading. Now, if I can choose this, there's more than one method to solve this question, but if I were to choose this method, say I lift them up and I take them apart, I actually see these two triangles, both right angled, at the same time isosceles. Okay, and they have the same area. Now I need to find the unshaded portion, that means I take away that gray areas where's the overlap. Okay, now if you can see, if I'm going to draw out the gray area here, okay, and that's this corner here, imagine like I'm drawing a right angle symbol, this is a square here, okay, and here over here this is similarly a square. Okay, can you see? Right, this is what it means. There's an overlap, so that means this square is going to, this corner of this triangle, this square part is overlap each other. Now with the information, let's look at if I can find then the length of the square, which here, since it's given, okay, that the square is 9 square centimeter, then because I know that squares are very interesting shapes, that the areas are square numbers actually. So if the area is 9 square centimeter, that will mean the length of the square will be 3 centimeter. Why? Because the area will be the length squared, meaning you will have to be 3 times 3, that's 9 square centimeter, right? So because the 9 square centimeter was given, I could deduce that the length of the square was 3. Now that said, I'll be able to identify that here, okay, the length of this part of the shape, okay, here, is a 3 by 3 square. So this is 3 and this is 3. And as well, this is 3 and this is 3. So if I fill in the missing numbers right now, okay, I will know that here this is 3, here's this 3, as well as this is 3 and this is 3. And then with the portion that's given, here is 8 and here is the side here that's being cut off the corner here this way is 8. Now that said, are you able to see that I have the length of one triangle, one side of the isosceles triangle, okay, being 11 centimeters. So from here I can get to the next part. That means the length of one side of the isosceles triangle, okay, here, in the sense that this is the right angle and here, is equals to 8 plus 3 and I get 11 centimeter. Okay, so looking at ABC now, I have these two triangles. I'm actually able to get the area of, say, the two triangles. So let's say I find the area of the two triangles here, these two triangles. Area of these two triangles, there will be half times base times height. There will be two triangles times half times base 11 times height 11, because it's as isosceles, right? So you have 11 centimeter by 11 centimeter. Okay, and that will give me 121 square centimeters. Okay, so here from this point I can find the unshaded portion already. The unshaded part, the unshaded area, will be the two triangles 121 minus 1 gray square here, that's 9 square centimeter, and then minus another 9 square centimeters is found in the other triangle because it's an overlap, right? And now that will get me 103 square centimeter. So that's the answer for this question, 103 square centimeter. Now alternatively, I can find the area of one triangle that's here. Okay, alternatively, if I were to highlight this part here with yellow, okay, so this is the space here, the unshaded part, as in one unshaded part. Let me color this in yellow. I'm trying to find one of these. Okay, alternatively, this is another method. I can find the area of this triangle, half times 11 times 11, still the same formula, and this time round you get me 60.5 square centimeters. And then here I take away 1 square, over here this is the 1 square, so the area of this yellow part will be 1 part, okay, of unshaded area of one unshaded part, okay, to be exact. Area of one unshaded part will be, pardon my handwriting because it's a bit difficult to write on this device. So I have 16.5 minus 9. That will give me 51.5 square centimeters. Okay, so that's one area of one unshaded part that's colored yellow. Not right now, like to help you to be able to see clearer. So add together these two parts. So that may be the area of the total area of the unshaded parts. Okay, so that's the total area of the unshaded part will be 2 of this. So 2 times 51.5 and that will actually end up being the same answer as the one previously, 103 square centimeters. Okay, alright, so make sure you have a unit. Now you can choose either of the method to solve, and if you have the time to, when you're done with the paper, you can use the other method to solve the question to check whether you got your answer right. Okay, so this is question 13, paper 2, SetA revision paper.